we're going to work through this example before us. It says, a study of the dining habits of various income groups in a particular suburb produces the results shown in the table below. So here we have the weekly income of the people from $100 to $1,000, and then the number of restaurant visits per year, as you can see here. Now, what we need to do, first of all, in part A, is use this data to calculate the least squares regression line, giving your answer correct to 2 decimal places. So to do that, the first thing we're going to have to determine is what my explanatory and what my response variable is. So this is my explanatory variable, and this is my response variable. Explanatory variable, because your weekly income is going to explain how often you are going to restaurants. So just thinking it through logically, we can come to that conclusion. So this is my X and this is my Y. So my explanatory variable, the weekly income, explains how often they're going to restaurants. Okie dokes. The next thing we need to do is input this data into our CAS calculator. So here's something I've prepared earlier. I just came to lists and spreadsheets and I popped them all in. I made sure to give them appropriate headings as well, so income and visits. Then the next thing that I'm going to do is I'm going to go menu, I'm going to go statistics, I'm going to go stat calculations, and I'm going to go linear regression A plus BX, okay. Then I'm going to say let X be my income because that's my explanatory variable, and Y be my visits because that's my response variable. Hit OK. And then what is produced for me here is some answers. So here you can see that A is equal to 1.2 and my B is equal to 0.0854. So let's come over here now and let's write down what we've been told. So we've been told that Y is equal to, now my A was 1.2 plus my B is 0.00854 and of course X. Now, when answering these questions, you have to be careful. I really shouldn't have introduced X and Y. I should leave them as the explanatory variable and the response variable, meaning I should just leave them as the weekly income and the number of restaurant visits per year. So I'm just going to leave them as they are. I'm not going to introduce variables not mentioned in the question themselves. So that means I'm going to change them. The other thing I need to make sure is I'm sticking to this 2 decimal places as well. So instead of Y, I'm going to go number of restaurant visits. So I might write restaurant visits, I can't spell, restaurant visits is equal to 1.20 because I needed to 2 decimal places. So I'm going to put a 0 there, plus, now this is going to be 0.01. That's now 2 decimal places there. And then I'm going to times that by the income. And that's going to be my answer there. Perfect. So let's give that a highlight. Next, the next thing we have to do is interpret the slope of the equation. So what is the slope of the equation? The slope of the equation is this, which is the gradient. And this is where you look at your template that we spoke of before, and that will show you how to construct your answer. And here is one that I have written previously. So here it says, on average, the number of restaurant visits increases by 0.01 visits for every extra dollar of income. So that's because you've got 0.01 here. It's positive, so it's increasing. You just need to make sure that you follow your template to answer that correctly. The next thing that we have is the y-intercept a valid statistic in the context of these variables? So remember, when you're thinking about the y-intercept, you have to consider whether or not it's realistic, because there are some instances when it's just not going to be realistic at all. Remember, if we come up here, it's saying that my y-intercept is 1.2. So in other words, y is equal to 1.2. And we know that the y-intercept occurs when x is equal to 0. And x is, of course, in this example, income. So it's occurring when income is equal to $0. So in other words, it's saying when someone's income is $0, on average, they're going to restaurant visits. I can't spell restaurant. Restaurant visits. 1.2 visits. So if someone has $0, on average, they're going to the restaurant 1.2 times. Does that make any sense? And it actually does make sense, because you might not be paying. So if your income is $0, maybe you're just not the one paying. And it makes sense that you're not going that often if you're not earning any money. So I would say that the y-intercept is valid. you could still go to a restaurant with no money. Someone else might pay for you. So I'm providing some rationale as to how someone with zero money could be making 1.2 visits. Okay, the next thing we have here is how many restaurant visits per year would you expect for someone with a weekly income of 340? So what we're going to do here is we're going to take our rule and I'm just going to sub into the income spot what we've been told. So that means we're going to come here and I'm going to go the visits, and I should stick to what I've called it. I've called it restaurant. I don't want to spell restaurant anymore. Restaurant visits is equal to 1.2 plus 0.01 times, and then I'm going to put in 340. And then when you put that into your calculator, what you're going to get out is 4.6. Therefore, 4.6 restaurant visits. So if you're earning that much, you'd expect 4.6 restaurant visits right there. Then our last one here. Use your equation to predict, so we're predicting, the weekly income of someone who visits 14 restaurants per year. Comment on the reliability of your prediction. Okay, so let's first predict it. So what we're going to do here is we know the restaurant visits. We know that's going to be 14. So we're going 14, and then I'm going to go is equal to 1.2 plus 0.01 times, and what I'm trying to figure out is their income. I'm going to have to use my CAS calculator to help me out with this one. So I'm going to come over here, and of course you'd have to use your CAS for this one as well. I don't expect you to be doing this in your head. Okay, and now we're going to use the CAS for this one as well. All right, so we're coming over here. All right, so I'm going to go Control Doc. I'm going to go to Add Calculator, Menu, Algebra, Solve, and then I'm going to type in 14 is equal to 1.2 plus 0.01. Then I'm timesing that. Then I'm just going to put X and then a capital X solve, comma X, because I'm solving for that. And that all looks good. I go Enter. So I'm going to get 1,280. So once all is said and done here, X is going to be 1280. Therefore, weekly income is equal to $1,280. Now, the other part of this question is asking me to comment on the reliability of your prediction. So when it's commenting on the reliability of the prediction, what it's saying here is, am I extrapolating or not? And I am extrapolating. So what this part is saying is, are you extrapolating? This is extrapolation. And the reason why I know it's extrapolation is because if we come up here for a moment, you can see that I have 5.8, 2.6, 1.4, 1.2, 6, 4.8, 11.6, 4.4, 12.2, and 9. 12.2 is the biggest. I don't get anything at 14 because I wanted 14 restaurant visits and I don't reach 14. So that means I'm going outside of my data range in making this prediction. So because I'm going outside the data range, this is extrapolation, and therefore this is not going to be very reliable. Therefore, not very reliable. And remember, the reason why it's extrapolation is because we're dealing with a y of 14, and that's outside of our range there. But that is how you approach that question. Hopefully you found this useful.